The best way to get better at programming is to practice. And in this example, we're going to write numbers to a file, but previously we assumed that everything was going to work okay. In this example, we're going to look for how to write good, robust code that's going to be capturing exceptions in case there's problems. Now, as always, this file is available for download, provided in the link in the description below. You can download it from that website. Pause this video, attempt it on your own, and then check your answer, or if you get stuck, you can follow along. All right, so let's get started. Here's the program that we worked on before, and it's in entirety. Now, I provide this for us so we can start off without having to rewrite it from scratch. So let's take a look at some things that we might expect. Over here, we want to do a try up very early on. You might say, well, why am I doing this try? Well, this try is going to be about opening these files. File I/O is a common place that we can run into exceptions. So all of this is going to be inside of a try. And then we're going to have the except. Now, you might ask, well, what type of exception might I deal with? Well, a common one is an I/O except. So I'm going to type in I/O. And you'll notice that there's an I/O error. That's a type of exception. And this is pretty good because it relates to all different types of I/O errors. And this is typically what we're going to see. Reasons that we might have an I/O error could be that a file name was entered in incorrectly. It could be that we don't have permission to write to a file in a given folder. Maybe our hard drive is full, and so we can't create a new file. So there's lots of different reasons why we might have an I/O error when dealing with files. So I'm just going to print error accessing files. Now, this does not tell us which file. We could maybe put around each individual file and let us know. We might want to give some additional information. Notice if I put in I/O error dot, I have a variety of different properties that I can use in order to check for things, such as maybe a string error, an error number, even the traceback. So there's a lot of different things in here that I can have, and you can just kind of look through these and see some of the different ones that are available to you. But this gives you some basic ideas of what you can expect. Now, for our case, we're not going to worry about those. We're going to keep this simple. Now, the problem is, if we get this working, I'm going to run this real quick. And notice that I still got an error, but it was a different error. It was a value error instead of an I/O error. If I look at my file, you notice that instead of having a number here, I have a dash. And maybe this dash was given because someone was typing it in and the dash is right next to the 0, and so they mistyped. Maybe it's because there was some corrupted data that came in. Who knows? We're not worried about why the error occurred. We just see that, look, it gave us an error and it stopped running the application for us. We don't want that. Now, you might be asking, well, why didn't it catch that error? We had the try except. Well, my except is catching I/O errors. That's all it's looking for. And there's lots of different types of errors that Python can throw. So what this does is this means that we need to catch a value error as well. The problem with this is that once it finds the error, it bypasses everything at the end and goes straight to the exception, which means that if I run to my first error, my program exits out. And that's not real effective. So let's look at another thing we can do. And what I'm going to do is I'm going to put a try inside of my for loop. I'm going to say except and value error. Now we'll do a print error converting line. I can use line because line is outside of my try except block. If I try to use far or Celsius, I would have had an issue because those are just inside my try block, and therefore I cannot see those values. Now if I go and try to run this, you'll notice that we get an error converting 3, but if I come and look at my Celsius, you can see I have different values in here. Now I only have 9 instead of 10 because of the one error, but it kept on processing even after it hit that error. And that's the nice advantage, is if I figure out where to put my try excepts, I can catch errors and then let my program continue if it makes sense. Like, for example, maybe I have bad data inside of a file. That doesn't mean the whole file's bad. Likewise, I might have a problem writing out to temp out for some reason. Maybe it's just a temporary thing. Well, I'm going to come down here. I'm going to say except IO error. Error writing to output file. So this is going to let me catch IO errors. And this is going to be IO errors with this associated try. Now, what happens if there's an error that's not that value error or the IO error? Well, we can do except exception. And this is kind of a generic catch. It's going to catch anything else that we might have. Now, I don't usually recommend this. I recommend looking for the values that I know and the types of errors I'm expecting. This trailing exception, though, can be good as kind of a catch-all, and in case there's something like we need to write to log files. There's 2 other optional clauses you can use. One is finally, and it's often used whenever we want to make sure we're closing a file or closing a folder or network connection, something like that. The other one is else. And that's if there was not an exception, what do you want to do? So it's nice to have in there as well. Usually it's not necessary, but it is available to you. So this provides you some good ways to make a little bit more robust code and handle yourself a lot better, making it so your programs are less likely to crash and frustrate your users. If you enjoyed this and want to keep on getting better at programming, I recommend that you go ahead and subscribe and look for our other videos on these topics on how to get better at programming.